We're now going to go through finding the determinant by hand for some 2x2 matrices. So find the determinant of each of the following. So what we're going to be doing is using this little formula here to help us out. And remember, you only have to do this by hand for 2x2 matrices. Anything that's bigger than that, you would use your CAS calculator. So let's zoom in here and find the determinant of A here. So here I'm finding what the determinant of A is going to be. And to do that, what you do is you go, all right, multiply these two together. So that's going to be 3 times -4. And then you multiply these two together, 2 and 6. 2 times 6, and then you subtract them from each other. So you're multiplying diagonally and then subtracting the products. So there it is. So that means what we're going to end up with here is -12 minus 2 times 6 is 12. So -12 minus 12 is -24. That's going to be our answer there. So the determinant of A is -24. Now, what does this tell us? Well, because we didn't get a 0 out, that means the inverse exists for matrix A. That's what it tells us. Let's now go into the next one here. You might like to pause it and see if you can do it yourself. We're finding the determinant of B here. And remember, what you do is you go 4 times -8, 4 times -8, subtract 0 times 0, 0 times 0. So what we've done there is we've simply multiplied diagonally. We've multiplied those, and then we've subtracted that by the multiplication of this diagonal of that one. And that means what we're going to get here is 4 times -8 is -32 minus 0. My answer will be -32. And remember, what does this tell us? It tells us because we have a number here and not 0, we didn't get 0 out, that means the inverse exists for this matrix. Let's now move on to our last one here. Again, you might like to pause it to see if you can do it yourself. We're finding the determinant of C here. And what you're going to do is 1 times 6 minus -3 times 2, -3 times 2. That's going to leave me with 6 minus, now this is -6 here. You have to be careful if you've got multiple negatives here because a negative and a negative make a positive. So my answer here is going to be 12. So just be careful there with dealing with your negatives. And again, what does this tell me? The fact that I didn't get a 0 as my determinant tells me that yes, this has an inverse function. So let's write something up here just to kind of remind us of that. We'll put a little asterisk here. You could say all of these matrices have an inverse matrix. And why do we know they all have an inverse matrix? It's because none have, that's not how you spell have, that's how you spell hat. My goodness. None have a determinant that's equal to 0. So that's what we know. That's how we do it. Before we move on, we've already spoken about it, but how do you put this into your CAS calculator? The way that you put this into your CAS calculator would be going menu, matrix, and then you've got the determinant there. Or if you wanted to, you could just type in DET and open up a bracket. If you've then already defined a matrix as a letter, you could just put in the letter as we did previously. Or let's just say you haven't, you could come over here and you could go 1, 2, 6, -3. That's not a negative, -3. And if we've done this correctly, as I have by hand here, the answer should be 12. And sure enough, it is 12. But remember, you need to know how to do find the determinant of a 2x2 matrix by hand. Anything bigger than that, then you can use your CAS. Hopefully you found this helpful.